All right, so section 4.8 is all about isosceles and equilateral triangles. So let's go ahead and take a second, and we're going to focus on isosceles triangles first, and then do equilateral triangles after. So isosceles triangles have two congruent sides and two congruent angles. So because isosceles triangles have so many special properties about them, we like to name the different sides certain things. So the two congruent sides are also called the legs, and the angle where the legs intersect is called the vertex angle. And then the side opposite the vertex angle is the base, and the angles along the base are called the base angles. Let's draw an example of that, because that was a lot of vocab. So let's draw an isosceles triangle, which means it's going to have two sides that are congruent, which we can show with our tick marks, and then two angles that are congruent, which we can show with our arcs. The two congruent sides are called the legs. So this is a leg, and then this other side is going to be a leg, because they're the two sides that are congruent to each other. The other side is called the base. So we have two legs that are congruent and a base. So those are our three sides. Now we have names for the angles. The angle where the legs intersect is called the vertex angle. So this point up here at the top is my vertex. And then the angles along the base are called the base angles. So this one is a base angle. And then this one is a base angle. So you can just think, I have my triangle. If the bottom is the one side that's not congruent, it's going to be my base, which has the base angles. And then we have our legs that meet at the vertex. All right, with isosceles triangles, we also have an isosceles triangle theorem, which says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if we're given sides, then I know the angles are congruent. And then if two angles are congruent, then the sides opposite those are congruent. So if I'm given that two sides are congruent, I then know automatically that I have two angles congruent. Similarly, if I have two angles that are congruent, I can then say, okay, two angles are congruent, that means it's an isosceles triangle, which means two sides are congruent. So we can draw arrows across, and then I have two sides are congruent. So we can draw arrows to the opposite sides or angles of an, it's supposed to say isosceles triangle to clearly identify which sides and angles are congruent. So let's do a couple examples of that. On the back of your paper, you have 4 problems that are all isosceles triangles. So if AB is congruent to BC, which two angles are then going to be congruent? It helps me at least to draw the angles, and then I know angle A is congruent to angle C. Similarly, on the second one, we're given angle E is congruent to angle F. So now, if two angles are congruent, which two sides are congruent? We can draw your arrows across. So then DE is congruent to DF. All right, do the last two on your own. All right, let's check. Draw arrows across. So angle H is congruent to angle G. And then draw your arrows directly across. So KL is congruent to JL. these properties and combine it with our triangle angle sum theorem to now find missing side lengths or missing angle measures of isosceles triangles. So your first step every time is to draw arrows to identify your congruent sides and angles. And then your second step is to use triangle angle sum or congruent sides to solve. All right, so let's look at number 1. I have JK is congruent to KL. So then I know that angle J is going to be congruent to angle L because those are my opposite angles. So if angle L is 68 degrees, then angle J is going to be 68 degrees. Now I just want to find the measure of angle K. That's supposed to be an X. What do all angles inside of a triangle add up to? 180. So we can do 68 plus 68 plus the measure of angle K equals 180. Add these up and subtract to get the measure of angle K equals 44 degrees. Alright, number 2. Same thing, we have 2 congruent sides, and if it helps, you can flip your paper so those 2 congruent sides are like the 2 that are going up. So now I know that these are going to be my 2 congruent angles. So if C is X, that means that E is also going to be X. So we can set up an equation where all 3 of these add up to 180. So 106 plus X equals 180. Combine like terms, you get 106 plus 2X equals 180. Subtract, you get 2X equals 74. So then X equals 36 degrees. So now both of these are 36 degrees. All right, pause the video right now. You can use this same thinking to do numbers 3 through 6. All right, quick notes on equilateral triangle. So, an isosceles triangle had 2 congruent sides and 2 congruent angles. An equilateral triangle has 3 congruent sides and 3 congruent angles, which basically just means everything is equal, right? A is equal to B, which is equal to C, and AB is congruent to BC, which is congruent to AC. So if a triangle is equilateral, so if all of my sides are equal, then it is equiangular, so all my angles are equal. If triangle is equiangular, so if I'm given all my angles are equal, then it's equilateral. If I'm given all my sides are equal. Basically all that means, if you have all the sides are equal, you can assume all the angles are equal. Or if you have all the angles are equal, you can assume all of my sides are equal. They go hand in hand together. So since all angles are congruent, then every angle of an equilateral triangle is always 60 degrees. Star this, underline it, circle it, square it, something. It's very, very important. Every single angle in an equilateral triangle is always 60 degrees. So let's use that to solve some problems here. So, measure of angle C. We have 2 that are 60, so that means C is 60. The length of BC. If my triangle is equilateral, that means every side is the same length. So every side is going to be 9 feet. All right, number 12. We have an equilateral triangle here because all of my sides are congruent, which then means that all of my angles are congruent, which then means that they are all 60 degrees. Easy. Last one. If triangle PQR is an equilateral triangle, solve for x and y. So that means that all of my sides are congruent. So if I'm trying to solve for y then, I can just pick any two sides and set them equal to each other to solve for y. So let's just pick these two. So 14y minus 59 equals 9y plus 1. Combine our whole numbers first. We get 14y equals 9y plus 60. Subtract our y's over, you get 5y equals 60. So you can divide by 5 and you get y equals 12. Alright, we solved for y. Now we want to solve for x. I know that this is an equilateral triangle, which means that all of my angles have to be 60 degrees. So we can just take 7x minus 3 and set it equal to 60 and solve. So you get 7x equals 63. So x equals 63 divided by 7, which is 9. So there you go. Equilateral triangles are a lot easier. All right, once you have that, you have some practice problems on the back for homework. This was the homework. And don't forget to do those problems on page 2.